Automatic drone. This demonstrates how the LPG section can be used to create sounds using alternative sources for the audio and volume signals, and also how to use LPG signal outputs, which are audio connections, as control voltage sources to modulate other parameters. Here, cutoff 1 is turned down, so we don't hear notes that are played in a conventional manner with the keyboard or the sequencer. The function 1 inverted output is connected to the LPG2 level input to supply constant high volume when no notes are being played manually or via the sequencer. This allows any sound connected to the LPG2 signal input to be heard at all times. That signal comes from the source carrier wave output. The pitch of this wave is being modulated or varied by itself via the LPG2 signal output. This causes some fluctuation in the pitch. The source modulator wave output is also modulating the fold amount. Adjust the ratio, fold and mod knobs to find different resonances and sweet spots in the sound. Easy sub-bass. This sound uses the modulator wave to create a low frequency sub-bass. Usually the modulator wave is not heard. Instead, it's used as part of the frequency modulation process, which shapes the carrier wave that is the wave that we usually hear. However, in this patch, we've connected the source modulator wave output to the LPG1 signal input. This overrides the default connection from the carrier wave to the LPG1 signal input. So now we hear the modulator wave instead of the carrier wave. The modulator wave tracks the pitch of the keyboard, so it's playing the same notes as would be played by the carrier wave, but generally at a lower frequency, at least when the ratio setting is at the minimum position. If we increase the ratio setting from the minimum position, then we will hear that the frequency of the modulator wave rises. We want this to be a very deep bass sound, so we're going to keep the modulator ratio setting at the minimum position. I'll show you one more trick that we can use with this patch. It can sound a bit quiet because on a smaller system it can sound quiet. On a big system it can sound very loud, but because it's a very low frequency basic triangle wave, there aren't many harmonics to be heard through smaller sound systems. If we want to make this sound louder, we can duplicate the output from LPG1 into LPG2 and then pass that on to the main output. So if we connect the LPG1 signal output to the LPG2 signal input, and then if we also duplicate the default connection from function 1 that is going to the LPG1 level input, if we duplicate that to the LPG2 level input, that will get the volume envelope to make that audible. So we will duplicate the wave in LPG2, join them together, and the result will be a louder sound. Amplitude modulation. Here, the wave generated by function 2 is used to control the volume of the carrier wave. Function 2 is looped to create a type of LFO, and the function 2 positive output is connected to the LPG1 level input. Now, when the phase of the function 2 wave rises, the volume of the carrier wave rises. When the phase of the function 2 wave falls, the volume of the carrier wave falls. This sound will play automatically when the connections are made. Remember, the carrier and modulator waves are always active, so as soon as a suitable signal is connected to the LPG1 level input, the carrier wave, which is connected by the default routing, will be heard at that volume. Adjust the shape and time controls for variations. Pitch explosion. This uses the carrier wave to modulate or change its own pitch in a very chaotic manner. The output of LPG1 is fed back to the source pitch input. So the wave that we are hearing is fed back and used to set the pitch of the wave that we are hearing, and this happens constantly. So the phase of the wave, the carrier wave that we hear, could be up here, down here, or anywhere in the middle, because it's all over the place. And then the phase of the carrier wave, if you like, its vertical position at any time, is used to set the pitch or the frequency of the wave, because it's fed back to the source pitch input. So this creates a very chaotic interface or relationship between the carrier wave and its own pitch. In this patch, I've also connected the function 1 positive output to the source ratio input, which just adds another element of texture. So the ratio will increase and decrease as the note fades in and fades out. Try different ratio settings to get the kind of sound that you want, and maybe try some reverb on the sound too. Play it louder. This is a patch which shows how you can amplify the volume of most patches that you make by duplicating the signal from LPG1 into LPG2. We used this technique previously with the sub-bass patch, and we're going to look at it again now a bit more specifically. So here is a basic sound, and the positions of most of the knobs are not really relevant here. The main knobs that you need to focus on here are the cutoff knobs, which both need to be at maximum. So here is a basic sound. Now, this is just passing through LPG1 as usual. So the carrier wave is going through LPG1 and its volume level is being controlled by the function 1 wave, which controls the attack, sustain and release envelope. We can make this sound louder by duplicating that sound into LPG2, and then LPG2 will be passed on to the main output. So here we've already got the LPG1 signal output patched into the LPG2 signal input. LPG1 is already being sent to the main audio output, but now we're going to put it also into the LPG2 section. So we've done that here with the yellow cable. However, before we hear anything from LPG2, we need to give LPG2 a volume level. So we're going to duplicate the volume level or the amplitude envelope that we're using from function 1 for the main sound. So we're going to connect the function 1 positive output to the LPG2 level input. When we make this connection, we will hear that the sound is louder because we've duplicated it and we've added the two sounds together, and therefore they're louder. So if sometimes it's useful to have a louder output from some of the patches. So when I make this connection, you will hear that the sound is the same pretty much, but louder. Organ bass. This is a simple combination of the carrier wave and the modulator wave, just using two triangle waves, one at a lower octave and one at a higher octave. So by patching the modulator wave to LPG2, we get to hear bass frequencies from the modulator wave and higher frequencies from the carrier wave. The modulator wave frequency is always linked to the carrier wave. So if we have the ratio setting at the minimum setting, then that will create lower bass frequencies based on the notes that we play on the keyboard. The modulator wave is fed to LPG2 via the source modulator wave output to the LPG2 signal input, and LPG2 gets a volume envelope which is the same as the volume envelope used for LPG1, because we're patching the function 1 positive output to the LPG2 level input. The LPG1 level input already has a default routing from the function 1 positive output, as we can see by the thin line on the front panel. We can add a few more harmonics and higher frequency details using the fold amount, but if we start to play with the frequency modulation settings, then that will upset the balance between the frequencies of the modulator and the carrier wave. Time machine. This is a kind of TARDIS sound effect which uses the woggle pink noise as a sound source. The woggle sample input can be used as an output. When we connect the woggle sample input to the audio signal path, so for example the LPG2 signal input, then we get to hear the woggle pink noise. We're going to introduce that into the audio signal path so that we can hear it, because inputs can be used as outputs and outputs can be used as inputs. We also need a volume level in order to be able to hear this as it passes through, or to allow it to pass through, the LPG2 with the low pass gate 2. Fuzz bass. This is a kind of overdriven guitar sound. It uses two techniques. One is to duplicate the carrier signal in LPG2 to make it louder, and it also feeds back the signal from LPG2 to the fold parameter to add a bit of unpredictable fuzz to the fold of its own sound. Screaming lead. This uses the LPG2 signal output to make complex changes to the ratio parameter. Both of the LPGs are in use here. LPG1 is active using its default routings from the carrier wave and function 1, so we hear notes as the keyboard or the sequencer is played. In addition to this, the modulator wave is routed to the LPG2 signal input, and the function 1 positive output is also sent to the LPG2 level input. So both LPGs are now receiving the same volume envelope from the function 1. This means that the carrier and modulator waves are combined in the audio signal path, so you hear both waves. You can hear this clearly if the ratio connection is removed, which also creates a useful lead sound. However, because the LPG2 signal output is connected to the ratio input, a harsher sound is created as the modulator wave causes rapid changes in the ratio amount.